Hello, everyone. So my name is Romain, and for the next 30 minutes, we're going to talk about how to deploy machine learning model and run them in your browser, on your laptop, or everywhere else, so that you can iterate quickly on building models using ONNX and WebAssembly. Just disclaimer, we're going to do a bit of Python and a lot of JavaScript. So, you know. Okay, so first question, just to get to know you a bit better. Who is able to deploy machine learning models from day one? Please raise your hand if you do. Okay, not so much people. So this talk for you. So the idea here is just to react to some hard truths that we get to learn about machine learning models through time. So there are many surveys that have been popping up for the past 10 years or so, and showing that field experience reveals that most models do not reach production, or at least some integration process or some integration stage in products. Some surveys go as far as 80% of models do not reach any state of integration. So that's a bit scary. I got some references for that at the end of the slides. And why is that? So mainly people are experiencing technical difficulties in integrating their models with basically products. So the difficulties in collaboration between data science teams and engineering teams can be a bit tedious for many reasons, especially lack of interchange formats or knowledge in between those two worlds. Also, the lack of user feedback is a major point. So basically, you develop your model in your own notebook, and here you go. It's ready for use. And so basically, without any user feedback, what we call in so many advanced stages the full MLOps loop, that you integrate user feedback so you can integrate new learnings, new findings, and iterate way farther on developing your models, is often lacking. And it's because it's not deployed, and also this lack of deployment shows difficulty to showcase the business value of said models. So basically, your stakeholders are not going to be following you and your team building models if they don't see the business value they can get from it. And last but not least, some privacy concerns are also expected by some users, especially in early stages. How do I trust some experimental team that they're going to manipulate some data properly? So yeah, and lots of laws and regulations are coming about that. What can we do better? So here's a proposal. You can deploy simple demos in the early stage at no cost. This is 2025, we have plenty of tooling. We're going to see how in a minute. We can use standard interchange formats for models. Again, we're going to see that in a minute. And we can benefit from inference at the edge. Okay, so let me reveal basically what's underneath those three ideas. So basically, how to deploy simple demos at no cost. You can make use of static websites and static website provider that can help you deploy that, or you can do that yourself, or on premises, or whatever solution you prefer or you have to use. You can use ONNX. ONNX is the de facto standard for machine learning models interchange format. This is completely language agnostic. We're going to see that in a minute. And finally, WebAssembly. WebAssembly has been all the rage in web technologies for the past few years. There is a WebAssembly 3 spec that has been released last week, I think, that's bringing some many improvements memory-wise and stuff like this. So let's benefit from all these new technologies and see how we can make them to the task of deploying machine learning models in the browser. So first, I'm sure most of you know ONNX, but just a recap so we get everyone on the same page. So ONNX stands for Open Neural Network Exchange. The name implies neural network, but it's basically any computational graph you can describe as a graph. You can represent it in ONNX. So not just neural network, but any kind of algorithm, even a custom one, you can represent it in ONNX. This is a common file format. It allows you to have some loose coupling between your training and inference stages, meaning that you can train a model in Python and use it, the ONNX model that has been outputted by this Python training in C++ or Go or Rust or whatever. So that is a good thing and something that is the integration with engineering teams if you are only in the data science world. It is language agnostic, like I said, and backend agnostic. This one is also a cool feature of ONNX because as you have like some agnostic format, interchange format, it can be optimized to run on many targets, not just CPU, not just GPU, but NPUs, etc. Any hardware accelerator can build a compatible backend within compatible runtimes for ONNX and be able to run your ONNX models at the edge. It can be in IoT devices and stuff like this. And so, yeah, interoperability is the key word of ONNX, basically, in the machine learning world. So ONNX models, how do I get started? Because, yeah, that's some nice thing you're showing up, Romain, but I'm using scikit-learn, I'm using PyTorch, or whatever framework. So for scikit-learn, you can use primarily the scikit-learn ONNX utility library, because this is just a simple utility library that allows you to convert your machine learning pipelines in scikit-learn to ONNX. Please note some operation might not be available, but it's growing very much. TensorFlow has built-in support for ONNX and PyTorch also. So all the neural network libraries support ONNX because there is some kind of direct translation to ONNX because those are already graphs. And this is heavily invested for deep learning. But basically any computational graph that you can express in Python, you should be able to express it in ONNX. So you can build a custom graph also with ONNX. You can develop algorithm in ONNX. So yeah. But this is not for the beginner in ONNX, for the advanced users. Okay, ONNX, great. I got like an interchange format, whatever. I can now visualize it. Like I said, this is a graph, so I'd like to look up the output of ONNX I will provide to my team. So there is a free tool. This is a pure client-side tool in the web, so no data is sent to any server. This is an open source one, and you can visualize really magically your ONNX graph. You can see inputs and outputs and properties, like the weights of each operator, etc. So we're gonna get back to this one later. And so, okay, great. I got my ONNX model some way using my preferred framework in Python. And now how do I make use of it? So you need an ONNX runtime, basically. The native ONNX runtime is provided in C++. So you can use it in your C++ code base, or you can use the Python binding, of course. Any binding, there are Rust bindings, Go bindings, Java maybe, I don't know. So maybe any language that you can think of. And of course, there is the web. So the ONNX runtime web is the one we're going to focus today. Okay, smooth transition to WebAssembly. Just a quick recap, if you have not followed the news in the craziness of web development. So WebAssembly is a recent standard compared to the whole web in itself. So it's a portable compilation target. By that I mean that you can compile once and it will run across many targets. Browsers, it can run client-side, but also server-side now. People are starting to make use of WebAssembly to have like a universal binary of some kind, somewhere in between. But yeah. This is interesting. So client-side and server-side applications are available for WebAssembly. For client-side application, most major browser supports it. Even on your phone, you can have access to WebAssembly on your phone. So that is actually quite interesting. And it provides you with what we call sandboxing. So sandboxing allows you to build some fast application, not as fast as native compiled code for your machine, but still it is pretty fast, faster than pure JavaScript. It is safe. Basically, it's sandboxed from any file system operation and stuff like this. And the standard is open, so anyone can look up the reference implementations, and yeah, that's it. And so all those features makes for a privacy-oriented target deployment for your machine learning model, actually, because everything is going to run on your machine and client side, and nothing is going to run server side. So yeah. Quick note, WebAssembly 2 is the current deployed and implemented version in every major browser. It supports only 32-bit memory indexes, so only 4 gigabits of RAM can be theoretically used. WebAssembly 3 is gonna switch to 64 bits indexes, so you will have many more amounts of memory available for your models. Okay, WebAssembly. There are some famous usage that you may already use in the data ecosystem. PyData was the first successful, maybe the biggest successful deployment of Python in the browser using WebAssembly. JupyterLite by our friends at QuantStack, most notably. So yeah, JupyterLite is great. It runs with WebAssembly. So you get JupyterLab in your browser client side, so pretty crazy. And PyScript, I think this one is from Anaconda, if I'm not mistaken. And so this one allows you to write Python in HTML tags. So that's for people who want to experiment. So that's pretty cool. And of course, ONNX Runtime Web. It makes basically heavy use of WebAssembly, either using CPU or GPU. And another one is Hugging Face Transformer.js. This is one that is specialized for, like the name implies, transformer models, so LLMs or SLMs. And we're going to talk a bit about this one in a minute. So let's get started. We're going to do some live stuff today. We're going to start with ONNX Runtime Web and focus on basic machine learning models just to get a feel on how to get started. So we're going to train a regressor with scikit-learn, export it to ONNX, and then integrate it in a static website. I'm not gonna live code, but everything I will show you is in a repo. I will put the link in the slide and in the dedicated Discord server of the conference. So let's get started. So we have like a standard training notebook, some data science team may have come up with. Here I'm just basically doing some housing value estimation model. So basically I live near Grenoble, and let's say I want to buy a new place, a new apartment in Grenoble. So I've fetched all the past values of apartment selling in 2024. So, okay, I get the data set. You know this way better than I do. You do some feature engineering. You do some train test split data sets, and then you build up the most fancy pipeline ever. So you have a standard scalar and a linear regression. So basically here, it's just that we have like some simple examples so that we don't get confused in all the complexity of the model, but whatever. And so here we go. And so we build the model is built, we evaluate it, we tried some prediction. Here I will just give you some hints. If I want to buy a 50 square meter and a 3-room apartment in the downtown Grenoble, it's 200,000 euros as per the prices of 2024. But still, that's not of importance today. Today, what is of importance is this. So I can use the sklearn2 ONNX library and use the 2ONNX function. So this one will basically analyze your pipeline in scikit-learn and transform basically every step of the pipeline to ONNX. There are built-in converters for most of the models and transformer of scikit-learn. If some of them are not there, you can build custom one. Or if you have some custom transformers or operator in scikit-learn. So basically what I do is give the pipeline. I will give an example of input. And I will set some offset targets. So basically, ONNX is very gentle in retrocompatibility between operators, etc. But every version of the spec, of the ONNX spec and the ONNX runtime, embeds some set of operators. So here we set some arbitrary offset target to 12. So basically, I want to export a model that is compatible up to the offset target 12. So. And then I can just rename the output value that my model, so the prediction value here is named value, and that's it, and we'll just specify the type, and we're done. So basically, I can write the ONNX model to a file. This is a binary file that is written to disk. Here you can see the graph actually in text. Okay, let me speed up a bit. Tick, 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 tick. Okay, and I can make use of my ONNX model in Python using the ONNX runtime Python binding. Here we can see we obtain some exact, some prediction which is in the same range as we did with the native scikit-learn model. This is expected that the results are not exactly the same in between your native Python model and the ONNX model because the ONNX runtime is not basically the same computational engine as your Python code, but that's expected, and usually the difference is very minor, but you have to be still careful and measure that. So, long story short, you got an ONNX model out of your training pipeline. So now you can just integrate it. So you just have to build a nice HTML file. So yeah, we're gonna do some old school web development. So HTML file, you build like a formula form here with inputs. So basically every feature I want to input the model, I'm just putting this as form inputs. And I will be able to retrieve the output of the model. So here I'm writing to a bit of JavaScript. So basically what you do here, this is not maybe the best practice in front-end development, whatever. I'm just doing this for simplicity. So we import from a CDN the ONNX runtime web as a module. We define some WASM paths. This is the framework works this way. And then we can basically instantiate. We can see this is exactly the same as in Python. Some inference session from an ONNX model. This ONNX model is on the same file system, so I can just refer to it as a relative path to the index file. And then I can just trigger an event when the form is submitted, get the input, and then I can build tensors as input for my ONNX models, run the model, and get the output value. Here we go. So this model is this one. Basically here you got all the four inputs feature for the model, and we have the value predicted value. And so basically it gives you this. So you have like an interactive web application, etc. And you can just run the model and you got the estimated value. Here it's a very, very basic example, like maybe the most basic one you can build, but at least I hope so that you get the idea on how it fits into the whole. But of course you can do some image processing, you can go way further than that. So this was just how to get started with ONNX runtime web. You can use transformer.js also. So this one is a bit different. It's focused really at the transformer architecture. Basically, it's made for you to run SLM and LLMs in your browser. I'm going to speed up a bit, and I'm going to show you an example using the latest Google Gemma 3 270 million parameters model, because this is the one of the most lightweight LLM you can find right now. This is completely open, and you can run it in your browser. You can just, you will have all the example in the Git repos, so you can inspect how it's implemented. And so basically we can ask it to, let me summarize the abstract of this talk. And if you wait a few seconds, it should come up. My machine is very old and nothing is ever sent to a remote server. And so I can just show you the network connectivity. If I redo a summarize, there is no request that is sent anywhere. So hello, local inference from LLMs in my browser using WebAssembly and WebGPU. So here you go. Okay. This is a lot of work for someone who does not know HTML, JavaScript, etc. What if I could do that automatically, like run a command and say, okay, you know what? Take this ONNX model, maybe a few metadata about inputs and outputs, and generate a static web app for me. And so I can deploy it anywhere. You know what? Let's do that. Just started like less than a week ago, a new open source project called Modelship that does exactly that. So quickly, I'm going to show you how to do what we call the extra mile of model deployment. So basically, I got my model, I got my ONNX, and I want to deploy it quickly so that my stakeholder can use it. So here you go. I've built, this is a very basic GitHub repo. We can see it right there. It's here. It's empty. And so I got an ONNX model, exactly the same one as we built before. So just what I want to do is build some metadata about the inputs, so we can find everything that we have seen in Neutron, meaning you get the data types of all your inputs and outputs, the shapes. You can specify some constraints about the input, so you can build some fancier app. And that's it. And so that's to show you that it works locally. We can just trigger it locally first. Everyone seeing my screen all right? Maybe a bit bigger. Okay. I can use, so UVX, use UVX for everything. So UVX model ship, static, so you will generate a static web app. Out of my model.onnx, you specify an output directory to build a bundle to be deployed and a metadata file that we just opened. So here we go. Okay, and now I have a dist folder with the web app that we manually built previously, and now it's built for us. So you got your form out of your inputs and outputs, and you got native integration with ONNX runtime, already filled with anything from getting the value out of the forms from tensor conversion in and out the ONNX model. So here we go. It's very basic for now, but you get the idea, I hope. Let me remove the dist folder, and you know what? We're gonna deploy that to GitHub pages right now. Like, I've written the smallest deploy pages setup ever. Like, just check out the repo, install UV, perform the exact same command we did, UVX model ship, etc. Set up the pages, upload to GitHub pages, and then it was just for me to get some QR code that I will share with you next. Fit, deploy to GitHub pages. Here you go. Let's commit, seeing the changes. Okay, and now, do we see it? Not yet. Okay, the changes are there. It's running. Come on. Okay. It's deployed. It should be deployed at least. Let's see. Here I got the URL of the GitHub pages deployment. Yeah, it has deployed and generated the application for me out of ONNX model. So I can run it. Again, there is no, except from the initial asset retrieval of HTML, GS, and CSS assets, and the ONNX model itself. There is no any web request that has been performed under my back. So pretty great for privacy. So here it was an easy example with GitHub pages, so you can get started in minutes. Okay, let's go back to the presentation. And so yeah, if you want to experiment yourself, like on your phone, like right now, you can scan this QR code. It will bring you to the app we've just deployed. And if you don't want to do that, it's a static website, so you can embed it in slides. So, you know, You can run it in your slides. So it's great for people that are not maybe technically inclined. So yeah, that concludes this whole section. Key takeaway from this presentation, just start shipping, basically, and that will be my last word. So my name is Romain. I'm an independent consultant. I have a company named Datelpia. I co-organize the Meetup Python in Grenoble. And I'd be happy to talk to you about any question you may have about this topic. Thank you.
Thank you very much, Romain. That was a great talk with concepts as well as practical demo. That's very appreciated. So now time for questions.
Thank you very much for a great talk. That was a really clear demonstration. I have a question because on the model, usually, you know, there is a part of that is also associated with the pre-processing that is required to pre-process basically the input. And sometimes if you have custom transformers of custom operation, how does that fit into the ONNX model?
Yeah, great question. This is always a trick that is hard to come by. Sometimes your pre-processing kind may be expressed in terms of ONNX operators. Sometimes. If that's the case, great. You don't have to do anything. At least you may have to build like a custom layer on top of it. You can build like an autograph and then embed the generated graph inside of it. So you get like a meta graph doing the pre and post processing in ONNX, and then you just plug the inside graph. If that's not the case, you don't have any choice, to my knowledge, but just to resort to your programming language that is your runtime, basically. If that's JavaScript, for instance, image processing. So you get maybe some MobileNet input features that you may want to use because it's normalized in some weird way. You will have to perform maybe the transformation yourself. I'm not aware of any other way of doing that. If someone is, please come up with a solution for that. Yeah.
Actually, that might be a good example where novel might be interesting because that way, you have a lot of processing, but if that could be translated in some way to ONNX, that would be interesting.
Yeah, with model ship, that's what I intend to do. So basically, for instance, if you deploy like a model with an image input, like you deploy MobileNet, let's take an easy example. You know that the image must be processed because it has, I think the normalization is minus 0.5 to plus 0.5, something like this. You may be able to express it in ONNX, but let's say you can't. You could define it in the metadata file as inputs, like I want to process it in some way, like MobileNet processing, or plainly define the scaling operation or whatever. And this is already a code generator, so you can generate the pre-processing and post-processing.
Yeah. Great talk, thank you. It's not a question, it's to answer your question. You can build custom operators and then rebuild ONNX runtime with your custom operator, but then you mostly have to code in C and do some shared dynamic loading. So yeah, you can always do crazy stuff if you go back this route.
Thank you.
But thanks for the talk, it's great.
Yeah, I forgot this one. Yeah, you can, but this is way more involved. But still you can. But you're modifying the ONNX runtime in this case. Yeah.
Hello. Sorry, just here. I have a question. I don't know if it fits the use case, but like, if I wanted to export the model on the website, for example, like I want to take the input from my client that is on my website, and I want to use a machine learning model to predict something based on these inputs. Is it something possible to do? Like for example, I have a website, and for whatever use cases I want to predict, I don't know, something based on everything he has done before on the website, and I put my model on the server side, for example, instead of client side here. Do you think it's possible? Do you think it's a use case that could be using ONNX model to be run on the website or not? I don't know if it's clear.
Sure, I don't understand the
Yes.
context. You're thinking like
Like you
hosting
put the model
somewhere?
server side, so no client side, you know, so
Mm.
it's on the server,
Okay.
like your ONNX file, and then you just like you have a JavaScript, so you can put the variables and everything. Is it something that you have heard of, or like, or not already?
If the model is held server side and you're
Yes.
doing the inference server side,
Exactly.
you can do
Yes.
anything. You just have to put an API on top of it.
Yes.
And you can build it yourself.
Mhm.
That's why I intend to also package as part of Modelship automatically.
Okay.
But yeah,
Yeah, it's
this,
possible.
actually this is the standard way of how people deploy usually
Yes.
models. Like you just put an API gateway on top of your model. You could deploy it as a container somewhere, and that's it.
Okay.
But maybe I did not understand your question.
Yes. No, it was
We
more
can talk.
Yeah,
more
we can
about
talk
it.
later. Sorry. Thank you.
Thank you. Anyone has any other questions? Okay, I have a couple of questions. Very interesting talk and very applied field. So firstly, do you fear any constraints coming from resources? Like you said that you are using an old laptop, but you fear any other bottlenecks that could affect the workflow of your application?
The constraints come from a few things. So first, WebAssembly is limited to 4 gigs of memory to be used. I think it's per process in the browser. So if your model is like, I've loaded Gemma 3, the latest one. It's already big, like the ONNX file is 1 gig already, and in memory, I think it's 2 gigs or something once it's loaded up. So this is the first thing, but this laptop is very old, and it can run it actually, so it's okay. And the other thing is, it just depends on the models you're basically running, and
Great.
I don't see any constraints that you.
It's amazing. And just a second question, what do you think about integration with platforms like AWS or Azure, or if somebody wants to like use your setup in that kind of a deployment setup, is it possible to integrate them?
Yes. This is just static assets, so basically just plain old HTML file, JavaScript and stuff. So basically anywhere that you can host it. So S3, for instance, you put a gateway on top of it, an S3 bucket for a static website, and here you go. And you can protect it with YAM or any other way. Here it's plain old GitHub pages, it's publicly available, so that might not fit the constraint of business or corporate environment. So, but any other way is possible. Yeah.
That makes it even more amazing. So I don't have any more questions. If anyone has other questions, if not, then we move on. We first of all thank Romain.
Thank you, everyone.